And welcome back. So we're going to continue with a bit of a solar update in reference to what you see here, which is our battery bank. Now in previous videos, we put together this angle aluminum that you see here along with the threaded rod, and before we put the bank in the service, we were talking about wanting to apply compression to these cells per the Eve specifications in order to get, I think they say about an extra 1,000 or so charging cycles if they run under compression versus if they don't. Well, if you remember, when we put this bank in the service, we kind of backed off of the ideal of compression. Yeah, we lose some charging cycles not having these under compression, but the amount of cycles that still remain quote unquote uncompressed means that by the time we exhaust the capacity of these and we have to replace them, battery technology is going to continue to advance beyond this point to the point where these finally hit end of life and have to be refreshed. We're going to want to change them out anyway to the latest and greatest. So losing those couple extra charge cycles because they're not under compression, again, that's kind of the reason why when we put these in the service, we made these threaded rod and this aluminum just something to kind of hold the pack together, to hold it in place. What we're going to do today is change this up a little bit. And by that I mean, and I'll put a link to his video in the description, but if you remember, LithiumSolar, put out a little video a few weeks ago in reference to these bus bars that he located. And these are the multi-layer bus bars that, as you can see here, are extremely flexible. And what this allows you to do is to put these cells together. And as these cells need to expand or contract, it will allow this bus bar to kind of push together or flatten out. Basically, this gives you the ability to get your flex without a rigid bar being in here and potentially damaging those terminals over time as that cell expands a little and contracts a little. Because as these cells charge and they're at a full state of charge, they're actually a hair thicker, a hair wider than what they would be when they're at a state of discharge. So as these cells cycle, they do expand a little bit and contract a little bit, and over time that can lead to connection problems in your bus bars. It could potentially lead to damaging terminals, things of that nature. So what we're going to do is that we're going to take all of the solid bus bars out and replace it with these multi-layer, much more flexible bus bars, just as LithiumSolar did to one of his packs, or his packs, I should say. And I'll put a link in the description to his video to give credit where credit's due. And inside the description of his video is the links where you can get these bus bars. I believe these bus bars, if I remember correctly, and I'll put a link to the AliExpress location. But again, like I said, to give credit where credit's due, I'll link his video in the description showing where he was first discovered and kind of talked about these bus bars. So these are the cell-to-cell or two-position bus bars. And just to kind of play around with it in case we want to try something different in the future, we also picked up the 4-position variety that you see here. Let's see. And you'll notice a little bit of a kind of playing around with an ideal here. Rather than going with threaded rods, since we're just looking for something to hold the cells together, I was playing around with some of this nylon-based webbing that is used to secure merchandise to pallets and heavy-duty boxes when going into shipment. And this is made to withstand, quite a bit of force prior to breaking. I'm going to go with something a little bit different than this. This is just kind of experimenting with this. What we're going to do is we're going to get rid of and drop all of this metal hardware. So I'm not going to go with threaded rod anymore or these angled aluminum. What I'm going to do is, again, since we're going to just need a structure to hold the cells in place and not really compress them, I'm going to go with something a little bit different in reference to kind of what you see down here. And this is just a little square chunk of lumber. And what we're going to have is this little bar is going to just kind of sit right there, kind of as you see on the end of this, and we'll have two of these per side. So instead of having all of this metal hardware in here, and again, this is just being done to kind of help hold the cells in place once all the packs are reassembled. And once we get this assembled, I'll bring it back and this will make a lot more sense. But also, just as LithiumSolar did in his video, we picked up some of this neoprene strip adhesive, and this stuff is a 1/4 inch thick. What we're going to do is, right now we have this cuttable, basically cutting block type material. It was that relatively easy to cut cutting board that came in. This is a type of plastic. And if you remember in the previous videos, we have one in between each cell. So we're going to pull this out and replace it with two of these 1/4 inch thick strips of this, again, neoprene. So that, in conjunction with putting our bus bars in, is going to allow these cells, as they need to basically expand a little bit and then contract a little bit, thus taking the wear and tear and stress off of those studs considerably. Now, I'm not going to say this would work in all occasions. You got to understand, a lot of people use these for a lot of different reasons, but our installation here is fixed. So it's not in a moving vehicle. It's not on a boat per se. So what we're doing here may not work in your particular situation. But here it should work just fine, because again, these batteries aren't going to be moved around or shuffled. And what we're also going to do is, just like we had in the previous video, where we switched out to these Allen screws to make a little bit better connection rather than the studs. To be fair, we're going to go back to the original studs and hardware for connecting the cells. We're going to use the hardware that came with the cells to connect the cells, since we'll be moving over to these flexible bus bars. So what I want to see is, using the original hardware, since we know what the connections were like using the bus bars that came with the original hardware, what is the connections going to look like when using these new flexible bars and the studs and bolts that came with it. We will have to add a little bit of wood. Have to extend our shelf out here at the end, because we're adding, again, a 1/4 inch thick piece of material in between the cells, times 16 cells. And that came up to about, I want to say about 7.5 inches extra in length, because you're going to have that little bit of a gap in between, which isn't there now. So again, it's just going to make our cell bank a little bit longer than it is today. So we're just going to tack on a couple extra pieces of lumber here and here, just to extend the end of our shelves out, and then we'll have to just kind of figure out and lengthen and or redo our one negative battery cable that you see here. So with that being said, what I'm going to do is get to work on disconnecting all of these bus bars and all these long mons. And then when that's done, we'll start to tackle tearing apart this this old angled aluminum setup and getting that out of here. I do apologize for the lighting in here. This has got the old school 60-watt light bulbs in the battery room, and so you can kind of see that yellow tinge in the light. But let me go ahead and start working on this. Like I said, we'll get these batteries disconnected. Once all that's done, I'll bring you back. Talk to you in a bit. Bye. And welcome back. As you can see, we've got our batteries kind of tore down at this point, and we're kind of getting everything reassembled. You can see that we've got our neoprene pieces in between our cells at this point. You can see we've got to just cut two pieces in between each cell, a top and a bottom. You can see it kind of gives you a nice little gap between the cells, so they got room to expand and contract as they charge, and hopefully relieve the pressure off those terminals. Because remember, in conjunction with this now having some room to breathe, Now these flexible bus bars are also going to allow for that movement to take place. As you can see, like we were talking about earlier, what's holding the bank together, and again, it's holding it together, it's no longer applying compression, is what you would probably just consider like a crate box that we've created here without the bottom. So instead of having the threaded rod and the two pieces of angle aluminum, we just went ahead and just replaced it with these wood pieces you see here, just these wood slats. We could have gone out and gotten longer threaded rod and replaced everything to account for the slight increase, as you can see here, in the overall length of the battery bank. The battery bank prior to putting the neoprene stopped right about here, and now it goes to right about here. So we just, as you can see, we added a small extension to the top of the table. So rather than go through the expense of buying all new threaded rod and then cutting that down to size again, since we're no longer using the threaded rod from compression and haven't been and didn't want to continue that going forward, that's why we just went ahead and just replace it with the wood slats that you see here. And it actually turned out, fairly well. We cut these pieces a little bit shorter than the overall length, just a hair shorter, probably about 1/8 of an inch or so shorter than the overall length of the bank, just so when we slid these in place, it had a little bit of a friction fit going down into place. In other words, kind of compressing these cells just ever so slightly. But as you can see, not very much at all, because you still have a gap between those cells there on the end. So what we're going to do next is get everything prepped for putting the bus bars back on. And like I said earlier, we're going to go back to using the original studs and nuts and hardware that came with these cells in conjunction, so that way we can test that hardware with these bus bars here. So that's what we're going to do next. We're going to get all those studs back in, get all of our electrical connections hooked back up, and work towards getting this battery bank back in the service, hopefully sometime later this evening. But once we get all these studs back in place, I'll bring you back. Thank you much. And welcome. So as you can see, we've got our bus bars installed at this point. We're just going through the process of getting our long mons wired back up to our individual cells. So I just want to show you this here, is that here you see one of the bus bars, obviously on our cells. And you can see where, it's got plenty of room in there to move as well as flex itself. Now, to give the original nut that we received with these studs a bit more of a bite, I'm just taking these flat stainless steel washers that you saw us use when we were using the Allen screws or Allen bolts, and just doing that with it. So, and you can kind of see that there. Drop that in place, and that helps to, give you a bit more perch on that bus bar, because it's now taking up a bit more of that kind of outside area. So you can kind of see what that ends up looking like. So you can see we've got our bus bar here, and yes, I don't have gloves on, but I'm being careful with what I'm doing. You can see that we've got a bus bar here. There's our flat washer there. On top of that, we've got our eyelet for our connection into our long mon for our battery monitor, and of course then the factory provided serrated stainless steel nut on top. So we're going to progress and go ahead and finish getting this side rewired, and then I'll bring you back. Thank you much. And welcome back. So you can see we've got everything connected at this point and tightened up. I've got all of our long mons tied back in, and we've went through the startup procedure on our out-back inverter to bring that and all the charge controllers back online. And what you're going to see in a upcoming video is that you can these are our Fortune 100 amp hour cells that were a part of our original lithium bank before we put the eaves online. And as we stated earlier, previously, I should say, we're going to put these 100 amp hour cells back in place. So you can see that we've got two banks of 16. We've got first bank of 6. Both banks are hooked up in parallel, as you can see, and then we've got the two banks hooked to each other just letting them top balance. I stuck a meter on these earlier, and there's literally 0 milliamp draw between the two, and they've been interconnected in parallel like this for the better part of the last couple of weeks. So they're top balanced and ready at this point. So again, we're going to take this 200 amp hour capacity, add it back into our lower shelf that you see there, and get us into well, that'll bring us up to 760 amp hours of capacity. So it'll allow us to do things in the winter, like in the summer months when the air conditioner is running. We can't run 100% of the house in the evening hours because we just don't have enough battery capacity, because running a full-size household air conditioner, it pulls about 2 to 2.2 kilowatt hours when it's running. But what we can do with the increased capacity, what the Outback inverter allows us to do is we'll tell it to run a percentage of the house in the evening hours over the summer months. So albeit not all of the house, but with that additional capacity, we'll be able to crank that up a bit. Now, in the winter months, because we're not running the household air conditioner, in the past, we could run 100% of everything that's tied into the solar system. We could run all of the solar system on batteries overnight, and it would only draw the pack down to about 80% state of charge because we have gas heat. Now, since then, we've added the garage, and the garage utilizes a mini split ductless system, which is a heat pump. Now, that heat pump, albeit as efficient as it is, the heat pump is just running an air conditioner in reverse. So when it's running, it pulls about 2 kilowatt hours. So even in the winter months now, with the addition of the garage added to the solar system, we can only run a percentage of the house. And that percentage currently, with just the 2 banks of EVE cells you see here, it'll normally run the house down to about a 70 to 72% state of charge. So with adding this 200 amp hour capacity into here, it'll allow us to either A, run with the same percentage we were running, but just discharge the batteries less, or B, what we're looking to do is to run a larger percentage of the house at night and then recover that charge during the day. In the winter months, because of the position of the sun and our solar panels, generally we can recover from a 70% stated charge back up to 100. Again, this is just with the 2 EVEs. This will change a bit when we add the others. But with the 2 EVE banks, we can currently go from 70 to 100% right about 2 o'clock in the afternoon, 2 to 2:30 in the afternoon Eastern time. So basically it means that we're leaving from 2:30 until 4:30 or so, when it starts to get dark out and the solar system starts to basically shut down at that point. We're leaving a lot of capacity that we could generate on the table. So that's why we want to run more of the house at night, because we know that we can generate it during the day and recover it. So that's the logic behind it. Now, there's going to be a couple things we have to be mindful of because we're mixing capacities. Again, these are only 100 amp hour banks. These are 280 amp hour banks. Now, in my previous videos, you'll notice that we've done this before. We ran 180 amp hour string alongside of these 2 100 amp hour strings, and then a fourth 145 amp hour string. Now I'll link his channel. His channel is linked into the description, and if you check out Off-Grid Garage, Andy down in Australia, he's doing a lot of testing right now with mixing capacity strings together. And a lot of the early stuff that he's brought to the table and has diagnosed was items that we've seen here doing it, because we did it for the better part of a couple of years. Generally, just due to the differences of just resistance differences alone, because these are 0.2 milliohms, I believe they're about 0.2 milliohms per cell internal resistance. These Fortune 100 cells are actually 1 milliohm internal resistance. So there's actually a higher internal resistance on these Fortune cells than there are these EVE cells. Just because of differences like that, and also the length of the wiring going to the main bus bars, everything has a play into that resistance factor going into that bank. And because of that resistance factor, Electricity, just like human nature, is that we're going to take the path of least resistance. Electricity is no different. So if it sees two nice low resistance banks to pull power from or put power into, that's what it's going to do. And then you'll see a larger percentage of what's coming out and what's going in handled by the lowest resistance bank, which in our case is going to be these two Eve banks here. And then as a last resort, it's going to hit these banks here. So in relation to some of it, it'll kind of govern itself and take care of itself. But there is one thing we'll have to watch out for. The system we have about 7.8 kilowatt hours of solar panels in various spots outside. On peak generation, we could easily put 90 amps plus into these banks after what's needed to run the house for recharge current. These Eves, as we know, can handle 90 amps worth of charge current, no problem at all. These Fortune cells, however, not the case. They are spec'd to a maximum of 50 amp of charge current. Now, when everything's hooked together, as we were talking about before, what I will do is when we get it all put together and have them hooked up, I'll come in here and run some videos and we'll do some amp draws and I'll kind of show you what I'm talking about. But one thing we have to be mindful of is that now, as long as this bank is functional and that bank is functional, at least one of the two banks is functional, those batteries down there, the Fortune 100 batteries, shouldn't see that level of charge current because it's always going to want to hit these Eve cells first. Again, just a lot of it just due to the lower internal resistance. Now, we could run into a situation where if this bank fails and that bank fails, in other words, both of these are completely out of the picture, and all that's left of those two Fortune banks, then at that point, it could very well see charge currents in excess of what they're allowed to handle. Now, there are various ways to combat this. One of the things that you could do is get a separate BMS for each one of these 16. So this strip would have its own BMS, so would that one. And that BMS would be separate from the one that's currently running the Eve cells. And inside that BMS, we could set restrictions to say, all right, you know what? Don't charge these particular banks up any more than 50 amps. And if it sees in excess of that, then it'll just disconnect the bank to save the batteries. Now, the only problem with doing that is that, as you well know, we run a Batrian BMS. So if I do that, now I'm running different BMSs or multiple BMSs that I have to switch using an app in order to see the status of. Not something I really want to get into. And like I said, generally, we should be okay. And I'm going to do this without putting a separate BMS on these strings. It's just, I have to be mindful of doing that there are limitations I have to make sure that we don't exceed. Now, I'm not saying that you do this. I'm not even suggesting that you do this. But when you're going to mix different capacity banks and have them paralleled together, it is something that you have to be mindful of. Now, I'm not up to date on the most current offerings for Batrium. So, now, one of the things about Batrium is that Batrium doesn't use MOSFETs, as you may or may not know. So in order for it to turn off charging current to your battery, it either A, has to interface with your charge controller and tell it, hey, stop charging the battery, something's wrong, or B, how we have it configured, if it sees a fault state, in other words, we can set it to where if you see too much charging current or something goes wrong with one of the cells in the bank, you'll see the shunt trip breaker there, and it just basically sends a 24 volt DC signal to the shunt trip breaker and gets it to basically disconnect all the strings from the bus bars, in a sense severing their connection from the charge controllers that you see there. Now, where putting a separate BMS on these strings would come in handy is that if it's a MOSFET-based BMS, then what would happen is the BMS would just turn on or off the ability to access those strings by turning the MOSFETs on and off. Again, it's not something I want to get into, at least not at this stage of the game. And if Batrium has maybe another way of doing it or a different offering, maybe we can get a second Batrium system in here, have it monitor the second group of 32 cells, and have it be able to talk to its own separate shunt trip breaker and then trip if it sees the charge current on that second string go too high. So that would be one way we can do it. But the issue with that is the expense of a second Batrium BMS, a second shunt trip breaker, separate bus bars. Basically, you would have from the battery bank perspective, you'd have a second completely separate system that you would be able to, kill power to if you needed. Again, it's not different ways of handling it, I guess, is what I'm trying to ramble on about, not something that we're going to get into. Now, like I said, I'll bring you back when we get ready to put these online and in parallel with these, and we will have them hooked into the Batrium BMS, so we'll have Batrium monitoring all 64 cells individually, and if it sees something go out of the ordinary, then it'll just hit the shunt trip breaker and kill power to all 4 strings. But like I said, I've done this for several years beforehand. I'll continue, but if I see too much of a problem with it, then we'll have to kind of fall back and regroup and figure out how we want to handle adding these, into this. The reason why I want to use these again is that these are very nice cells. Very, very nice cells. You can see they got the nice, big, beefy lug terminals on them. They're meant for EV use. They can withstand a nice high rate of discharge. So again, their only downfall is that they're spec'd to a maximum of 50 amps with a charge current. But like I said, they're nice cells. I want to use them. They're just going away sitting here, so that's what we're going to do. But I'll bring you back for all along that. I'll bring you back for that, and we'll kind of go through it, and we'll see if there's any potential pitfalls. I don't think there will be. Again, just because we did do this for a number of years before switching over to E's, where we did run 4 strings, and on 2 of those strings, I should say, yeah, 2 of those strings had different capacity. So 2 strings were at 100 apiece, 1 was at 180, and the other one was at 145. So we have done this before, but I just wanted to, ramble on, kind of rambling on, but I want to let you know that, there are things to be aware of when you're going to do that. But I rambled on long enough. Just wanted to give you a final view here and show you that we're all hooked up. We're all working. Like I said before, in the description will be the links to Lithium Solar, where he's got his video where he talks about these bus bars. I want to give credit where credit's due. That's where I found the link to order these. As I started saying before, we're trying to get to that first milestone of 1,000 subscribers in order to get the to gain more support for the channel. So if you can, click on that subscribe button if you haven't already. We're still about the 79, 80-ish percentile as far as views that are being done by what YouTube deems as unsubscribed members. So if you could take a minute, click the subscribe button. Hopefully we can get this channel up to its first milestone and continue to grow from there. But other than that, I'll stop rambling and I'll talk to you later. Bye.